Hello everybody and welcome back to math class. Today we're looking at problem solving, lesson 10.6, and this is on our unit of converting measurements. Today we're looking at converting between customary and metric, and specifically we're going to look today at converting measurements of capacity. So we're looking at cups, gallons, things that we would use in the kitchen, and we're going to get to do a lot of fun math, get to use all the math skills that we've been learning this year. So this is going to be a fun one. Buckle up. All right. Today the problem is Aaron is making fruit punch for a family reunion. He needs to make 120 cups of punch. If he wants to store the fruit punch in gallon containers, how many gallon containers will Aaron need? And we get to use this graphic organizer to help us solve the problem. So they've given us a conversion table. It looks a little bit different than the conversion tables that we've seen before for a couple of reasons. On the left column, they have gallons, quarts, pints, cups. And if I follow one of those across the row, it shows me how many gallons are in 1 gallon. Well, there's 1 gallon in 1 gallon. How many quarts are in 1 gallon? There's 4 quarts in a gallon. So you can see it's laid out a little bit different than the conversion charts that we've seen on the other lessons. Pints, there's 4 pints in 1 gallon, and cups, there's 16 cups in 1 gallon. So we have larger going towards smaller units, and likewise here, larger going down smaller units. Where it gets to be a little tricky is when I'm looking at a smaller unit and converting it to a larger unit. Remember when we saw that? Previously, we talked about dividing. I'm going to be dividing when I go from a smaller unit of measurement to a larger unit of measurement. Here that's shown as a fraction. Instead of saying that I'm dividing by 4, because there's 4 quarts in a gallon, I say that there are 1/4 gallons in 1 quart. Again, fractions are division problems. So all that's saying is the same thing as we see here, but that I would divide a gallon into 4 parts to make 1 quart. So 1 part over 4 is a quart of a gallon. I understand that's probably going to be very confusing to read it like that, and that's fine. As we work with it, hopefully it'll make more sense. So let's see. 1 quart is 1/4 of a gallon. Saying the same thing as saying that there's 4 quarts in a gallon. There's 1 quart in 1 quart. There's 2 pints in a quart. And there's 4 cups in a quart. Here we're getting more fractions when we go to pints. How many gallons are in a pint? Well, gallons are larger than pints, and there's 8 pints in a gallon, so there's 1/8 of a gallon makes 1 pint. Likewise, for quarts, since there are 2 pints in a quart, 1 pint is 1/2 of a quart. 1 pint for a pint, and there's 2 cups in a pint. Finally, cups, the smallest unit of measurement that we're dealing with for this problem in this table. Smaller unit of measurement, larger unit of measurement, there's 1/16 of a gallon in 1 cup. There's 1/4 of a quart in a cup, there's 1/2 of a pint in a cup, and of course there's 1 cup in a cup. Okay, so that's how we read a table like this. Again, anytime you see the fraction, meaning that I'm dealing with a smaller unit of measurement going into a larger unit of measurement. Okay, and that's also, we're going to probably be dividing in those cases. All right, So let's read, what do I need to find? Well, what do I need to find? I need to find how many gallon containers are needed for 120 cups. Because remember, the problem was he's going to make 120 cups, Aaron is, of punch, but he wants to put them into gallon containers. All right, so what information do I need to use? I need to use the number of cups, which I know is 120, and how many cups are in a gallon? Well, there's 16 cups in 1 gallon. How will I use this information? I'll make a table to show the relationship between the number of cups and the number of gallons. All right, so you guys can see that again. If you want to take your notes, I need to find gallon containers are needed for 120 cups. I need to use the number of cups and how many cups are in a gallon. And I need to make a table that shows the relationship between the number of cups and the number of gallons. Okay, so let's use that information to solve the problem. So, how many cups are in a gallon? Well, if I remember, I'll know it's 16. If I don't remember, I can use my chart. How many cups are in a gallon? There's 16. So down here, I'm going to fill in 16. Each cup, therefore, is, here's where my fraction comes in. So converting from smaller to larger, I have 16 cups in 1 gallon, but now I'm going from the smaller measurement to the larger, so I'm going to show that as a fraction. Okay, so each cup is 1/16 of a gallon. And completing the table below, I have my cups up top, 1 cup, 2 cup, 3 cup, 4 cups. How does that relate to gallons? 1/16, 1/8, 3/16, 1/4. You may be wondering, I understand 1/16 because there's 16 cups in a gallon, but where does 1/8 come from? Well, if you remember, the equivalent fraction of 1/8 is 2/16. So all they did was simplify. If you notice the 2, if I have 2 cups, that means I have 2 parts of a gallon, and the gallon is split up into 16 parts. Fractions, remember, the denominator is how many total parts there are. In this case, how many total cups are in a gallon? That's 16. How many parts do you have is the numerator. In this case, 2. Similarly, if I have 3 cups, then I have 3/16 of a gallon. So the number of cups I have is going to be my numerator. 16 will be my denominator. If I have one that looks different, like 1/4, that means it's equivalent to 4/16. The numerator again, how many cups do I have? How many cups total in a gallon? And all they did was they simplified it by dividing the numerator and denominator by 4. So I could figure this out simply by making the numerator the number of cups total and the denominator the number of cups in a gallon. And how I solved all these was I multiplied them by 1/16. Okay, we're going to learn about multiplying fractions a little bit later. You don't need to worry about that now for this, because I already know that he's going to need 120 16ths gallons containers. Well, that doesn't really help me, because what does that mean? That's where the fun part comes in. Because if you remember, we learned how to simplify big fractions. If I have a fraction like 120 over 16, I know that that's a improper fraction, right? Which means the numerator or top number is larger than the bottom number, which means I'm going to have whole numbers here. I may have some fractions left over, but for right now I'm going to have a whole number. So how am I going to find that right now? Well, I'm going to divide by the greatest common factor of 120 and 16. Okay? And do you remember how we found that? Well, we used our factor trees. And we factored till we got the prime factors of both numbers. So the prime factors of 120, if I'm not sure, remember, it doesn't matter which numbers I start with because they'll all lead me to the prime factors. So I just factor the numbers until I can't factor anymore. And I can't factor anymore if they're prime. If they're prime, I circle them. 2 is prime, 5 is prime. Why? Because they can't be divided by anything other than themselves in 1. How about 12? 12 can be divided to 6 and 2. 2 is prime, 6 is not. I get 3 and 2. And there are my prime factors. And then down here I'm going to write my prime factors. I have 5 times 3 times 2 times 2 times 2. So I have 3 2s, 3, and 5. Those are the prime factors of 120. How about for 16? Which is 4 and 4. And again, it doesn't matter. You could also do 8 times 2, because that's another way to get 16. Similarly, for 120, I could do 30 times 4. I could do, I think 6 times 20, but they'll all lead to the same prime factors. So if I start with 4 times 4, the factors of 4 are 2 and 2. So the prime factors of 16 are 2 times 2 times 2 times 2. Okay, so hopefully that rings a bell that we've done this before. To find the greatest common factor, I eliminate the ones that they do not share in common, and I keep the ones they do share in common. Meaning, do they both have 5? No. 16 has no 5s, only 120 does. So I get rid of that one. How about 3? 120 has 3 as a prime factor, but 16 does not. So I get rid of that one. Now, they both have 2, but how many 2s? 120 has 1, 2, 3 2s, but 16 only has, or actually has 1, 2, 3, 4. So it has 1 extra. So I'm going to get rid of that extra until I'm left with just the exact matching primes. And in this case, it's 3 2s. So the greatest common factor is 2 times 2 times 2. And I can solve that because what's 2 times 2? 4. And what's 4 times 2? 8. So their greatest common factor is 8, which means if I divide, again, my fraction was 120 over 16, I divide that by 8, I'll get my simplified fraction. Now I know 16 divided by 8 is 2, but maybe I don't know what 120 divided by 8 is. That's okay because I know how to do long division. So I know how to solve it. And what's 8? How many times does 8 go into 12? It can't go into 1, so I have to go to 12. How many times does 8 go into 12? 1 time. And how many times does 8 go into 40? Notice I brought down the 0. I had 4 left over. Brought down the 0, so I have 40 left. How many times does 8 go into 40? 5 times. Hopefully you remember that. All right? And 5 times 40. Sorry, 5 times 8 is 40. No remainder. So 15 is my number. And I'm left with 15 over 2. So I can leave that and say that Aaron needs because remember I was trying to find how many gallon containers does Aaron need. So he needs 15 halves containers. But that doesn't really make sense if I'm going to the store and I ask how many can I buy 15 halves gallon containers. They probably won't know what I'm saying. So I'm going to convert that to a whole number. And to do that, remember, fractions are just division problems. So all that's saying is 15 divided by 2. How many times does 2 go into 15? 7, right? 7 times 2 is 14, and I'm left with 1. And I can remember when I'm dealing with fractions and I have a remainder, that remainder, so this is my whole number. The 7 is my whole number because, again, it's an improper fraction. There's wholes. I take out 7 wholes. 1, whatever's remaining is my numerator, and 2 stays the same. The denominator always stays the same. So the simplified version of 120 over 16 is 15 halves, and convert that into a proper fraction, it becomes a mixed number, and I have 7 and 1/2. So that's my answer. So Aaron needs 7 and 1/2 gallon containers to store the punch. Will all of the gallon containers Aaron uses be filled to capacity? No, because this half, if he's buying containers, he's actually going to buy 8 containers, right? Because you don't buy just half a container, right? So he's actually going to buy, he will buy 8 containers, and 1 will be half full. There you go. So again, this was lesson 10.6. It's page 449 in your book. It was a very long one, but we got to do a lot of fun math in order to solve it. So I'm glad you stuck with me on it. The next part will be the example on page 450. So that video will also be going up today. All right, if you have any questions, feel free to email me, but I will see you next time.